Hi students. So the question we asked at the end of the previous video was, is it possible to power two LEDs off of one battery pack? So we are going to find out about that in this video. So you're going to need your two LEDs, resistor, our switch, two snap connectors, and three snap connectors. Okay, so this circuit's going to be a little complicated, but we'll follow the steps and we'll get it done. So first thing we're going to do is place our resistor in our circuit to protect our electrical components. Next, we're going to put a 3 snap bridge. I'm going to slide these guys out of the way because one of the first things we're going to add is our push button switch. And we're going to snap that into place. So now we've got a little mini loop here, and we're just going to let that be for the time being. Next, we are going to place our two LEDs next to each other with one row of pins in between. We're going to bridge them together with our 2 3-pin connectors, and now we see we have two circles, one with the battery in it, one without. So to connect all this together, we're going to bridge both of these guys together with our 2-pin connectors. And look at what happens. We are using one battery pack to power two LEDs. So what is going on here? We've created what's called a parallel circuit. And the reason it's called a parallel circuit is because all of our components are parallel to each other. They're almost forming parallel lines. And when we have a parallel circuit, it's a little more complex than a series circuit. The electricity has options as it flows through the circuit. It can come out of the positive, and it could turn and go through this LED and then back through the loop. Or it could keep going and then flow through this LED and flow through the loop. So what ends up happening is the electric current splits, and some flows some way and some flows the other. So electricity has more than one choice for how it's going to flow. It turns out that when we do it this way, we can push more current through the entire circuit with a small amount of voltage than we could if we put everybody in one big circle. So while series circuits are simpler to make and easier to understand, they require more voltage, whereas a parallel circuit, it's a little more complex, but you can do more with fewer batteries with lower voltage. So let's take a moment to remember how we talked about that electricity likes to take the path of least resistance. It likes to take the easiest way that it can. Both of these LEDs have a little bit of resistance in them. The electricity has to do work when it flows through to light up these LEDs and make the lights happen. We have our button switch in here. I'd like for us to take a moment to think, what happens when the button is pressed versus when it's not pressed? We learned in our previous videos that when the button is pressed, this closes and it makes it possible for electricity to flow through it. But when the button is not pressed, that is open and current can't flow through here. So right now, this is blocked because the button is not pressed. So electricity can only flow through either of the two LEDs. However, if we press that button, something crazy happens. Both of the lights go off. So let's think for a moment. Why would the lights go off when we close this part of the circuit, when we connect it together? What we're doing when we press this button is we provide an easy shortcut for electricity to travel through that's easier to flow through than it is to flow through the lights. So all of the current coming from our battery says, oop, this is the easy route, we're going this way. And it skips the two LEDs. So in a parallel circuit, when you install a button switch, it ends up doing the exact opposite that it does in the series circuit. In the series circuit, we press the button to turn the light on, Whereas in the parallel circuit, we press the button to turn the light off. Pretty interesting. So there you have it, series circuit versus parallel circuit.